In this video, I'm going to talk about the B part of the Monatomic Ionic compound worksheet, which is naming the compound. So when I give you the formula, you give me the compound. And so I'm going to first talk about the B worksheet, the steps, okay? Now, the A part, right, we go back to the A part, is the crossover method is if you start with the charge, you bring them down as subscript. That's the A part. But B part is opposite. When I give you the formula, you give me the name. So the formula, there is a subscript inside. So you have to start with the subscript and bring them to the top and add the charge on. So the process is, for example, I give you the formula ALN. You're supposed to give me the name aluminum nitrate. So what is the step? The step one is if there is no subscript outside of the formula, you add the 1. Okay, so ALN, there's no subscript. You add the 1 back. If there's a subscript on the formula, you're good. Okay, but there's no number, you add the 1. Because remember, you go back to the formula, to the step. When you have the 1 in the formula, you take away the 1. That means right now we're doing opposite. You give the 1 back to the formula. Okay, so AL1 and 1. And the subscript is on the bottom. It's on the bottom. Okay, and number 2, you circle the subscript and cross over to bring them to the top and add the charge. Now remember, positive first, negative next. So we're going to end up with AL1 plus and N1 minus. And AL is plus, N is 1 minus. So it should be fine. And then you weigh the charges, okay? And then the step 4 is, did you check the charge of anion? Do you need to multiply by 2 or multiply by 3? So we need to check the charge of anion. Now the N originally is a group 15, should be minus 3. But now the N is minus 1, so it's not happy. We need to multiply by 3 to the N. Now we do the same thing. On the top, I will divide it by the number we develop from both of the subscript. Now here, we multiply the number to the charge. We do the same thing for both cation and anion. Multiply the 3 to the N, multiply the 3 to the aluminum. Again, we use the anion to decide, not the cation. Because the anion, 15, 16, 17 group number. Each group number only have one number, only have one charge. So we only have one choice of the answer. You will not have the choice of like, oh, I have multiplied by 2, multiplied by 3, multiplied by 4. So only one answer. There's no doubt. Why don't we use cation to decide? Because cation, I can have multiple charge. Then how do you know which number you use? So we use anion to decide. Is the anion happy charge? If yes, you don't need to multiply. If not happy, you multiply. So here it's not happy. We multiply by 3 to both of them. So we get Al3 plus and N3 minus. And then finally, we can name them will be aluminum nitride. Now be careful. Do you need to include Roman numeral to the cation? Now the Roman numeral is like they're underneath the D block or they are underneath the zigzag line, except the 6 circle one. So aluminum is not the transition metal. It's not on the D block. It's not. But the aluminum is one of the 6 circles, so it's only at one charge. We don't write the Roman numeral number. But if they are on the D block, they are underneath the zigzag line, and it is not one of the 6 circle, then you have to give a Roman numeral number. So the notes here, I'm going to go over the first question. And the K2O, you start with K2O. So I write down K2O, but you put the 1 on the bottom because there's a missing subscript. You circle the number from the bottom and bring them to the top crossover. You get a K1 plus O2 minus. When we write the cation and anion, we don't write the 1. We write K plus O2 minus. Now the O2 minus is happy charge because O is 2 minus, so we don't need to multiply any number. And K is not the D block or underneath the zigzag line, so no Roman numeral. So the final answer is potassium oxide. Now MgI2, we write MgI2, and we're missing the 1 from the Mg, so we put the 1 on the bottom of Mg and bring the number to the top, and we add the charge. Okay, so we add the Mg2 plus and I1 minus. Now the I is happy charge, 1 minus group 17, so we don't need to multiply any number. And Mg is 2 plus, that's the right charge. So then the answer is magnesium iodide. Now on the MgS here, so they're missing the 1 here, so we put the 1 back and we bring to the top to get 1G1 plus and S1 minus. Now the S is not happy charge because S is supposed to be minus 2, so we multiply by 2 to both of them.
Burnett St. Philip, if you are in the building, please come to the front desk. Burnett St. Philip, if you are in the building, Please come to the front desk. Your ride is here.
So the Mg1 plus, the S1 minus is not happy charge. We will need to multiply by 2 to this. So we multiply by 2 to magnesium to get happy charge. So Mg2 plus S2 minus, and no warm mineral because magnesium is not translucent metal. So magnesium sulfide. Okay, now here the charge is happy. The P3 minus happy charge, and Ba is 2 plus. So we don't need to multiply. And let's say CuO, we start with CuO, but we put the 1 on the bottom because there's no subscript on there. So we put the 1, and then we bring them to the top. We got Cu1 plus O1 minus. Now O is not happy charge because it's supposed to be minus 2. We multiply by 2 for both of them. So I got Cu2 plus O2 minus. Now because copper is translucent metal, okay, and it's not one of the 6 that you circle, you have to give him Roman numeral. So it'll be copper 2 oxide. Now here, if you forgot to multiply by 2, your answer will be copper 1 oxide, which is wrong. Okay, and then the last two thing is 1 is multiplied by 3, right? 1 is multiplied by 2, depending on the group number and the charge. So then you give them the Roman numeral because they are the transition metal. So you have to be really careful is always check the charge of the N ion to see if they're happy, and then you multiply the number for both of them.